Hi and Assalamualaikum. My name is Siti Farah Alia binti Mokhtar and my metric number is S65496. Today, I will present to you about my proposal, which is study of HPTLC and TLC bioautography of polyphenol extracts of Malaysian honey. So for the contents of this video, we will talk about the introduction of this study, objective of this study, the methodology, and the expected results of this study. Now let's start with the introduction. For the first bee, we use Heterotrigona itama. This bee is a common species of stingless bee. In their hive, stingless bees and sting bees alike produce propolis, honey, and bee bread. The feeding habits and hive designs of stingless bees differ significantly from those of honeybees due to their biological differences. The next bees we use is Apistosata. These enormous honeybees are indigenous to ASEAN, primarily Malaysia. These are tropical bees that travel seasonally in most regions. During the change from the rainy to the dry seasons, individual colonies move between nesting locations, staying there for roughly 3 to 4 months at a time. And both of these bees have been discovered that it contains a range of polyphenolic chemicals such as flavonoids, phenolic acids, and other antioxidants. The common method we use for this study is HPTLC and TLC bioautography. For HPTLC, it is advanced chromatographic technique used primarily for the separation, identification, and quantification of complex mixtures of compound. HPTLC method will minimize the exposure risk of toxic elements and therefore it can be considered as an environment-friendly method. The next is TLC. TLC combines the ability to separate biologically detected bioactive chemicals with the separation powers of TLC separation of chemicals on a thin layer of adsorbent material, which is then followed by biological assays to visualize the bioactive zones. This study has 3 objectives, which is the first is to determine the chemical profile of Malaysian honey using HPTLC analysis. The second one is to evaluate antioxidant activity of Malaysian honey based on the TLC bioautography method. And the third one is to extract the polyphenols from the Malaysian honey. Next, we move to the methodology of this study. This study has 6 methodology. The first one is the preparation of honey extraction. Firstly, we have to take 100 grams of amberlite SAD2 resins and 250 milliliters of acidified water, which is in the pH 2.0, was used to elute 50 grams of honey. Then we need to aliquot 10 units of 50 ml centrifuge tubes. And the next step is 250 ml of acidified water and 300 ml of distilled water were used to wash the resin and honey sample mixture in the column. And the last is honey methanol extract was concentrated at 45 degrees while under vacuum pressure. The second method is extraction of polyphenols. In this method, we use maceration technique. It is to target chemicals are dissolved by the solvent's interaction with the solid material during the designated sitting time, and the mixture is strained or filtered to remove the solid residue from the liquid extract. The third method is DPPH, freeze radical scavenging antioxidant assay. DPPH is 2,2-diphenyl-1-p-cryl-hydrazine. In this method, antioxidants' capacity to transfer electrons or hydrogen atoms to neutralize the stable free radical DPPH. The color shift from purple to yellow that can be detected quantitatively using spectrophotometry. In this method, we also measure the UV-vis absorbance at 517 nm. The reaction was quantified with the percentage of inhibition, which is stated in the slide. The fourth method is FRAP assay. FRAP assay is to determine a substance or biological sample's antioxidant capacity. The overall antioxidant potential of materials, since it gives a measure of the total antioxidant capacity rather than the specific activity against a given free radical. Next is chemical profiling by the HPTLC. In this method, they have three stages, which is separation, identification, and quantification. Separation. HPTLC separates components of a mixture based on their differential partitioning between a stationary phase and a mobile phase. This allows for the isolation of individual compounds from complex mixture. The identification. Once separated, the individual compounds can be identified based on the characteristic retention factors, which are specific to each compound of honey and can be compared to reference standards. And the last one is quantification. HPTLC can also be used for quantitative analysis by measuring the intensity of the spots corresponding to separated compounds. The last method is TLC bioautography. TLC bioautography is for antioxidant constituent. This method was analyzed by the thin layer chromatography followed by DPPH. The antioxidant constituent were detected as yellowish green spots. Next, we will talk about the expected result. These are the expected results for the antioxidant activity that I get from the journal. The antioxidant activity was compared by the value of their inhibition concentration at 50%. Next is chemical profile of Malaysian honey. The expected polyphenolic chemicals found in Malaysian honey, such as flavonoids, phenolic acids, and other antioxidants, can be identified and measured using HPTLC. And that's all from me. Thank you.